So we're moving on to section 5.2. We're going to put an A value and a B value into our sine, cos, and tan graphs. So just remember that this is what your original sine, cos, and tan graph look like. And now we're going to apply some stretches and some flips. Because A and B, if they're negative, it causes flips. So here it says, what changed from the original function? So the original function is here in blue. I see that it starts at 0. So I'm talking about a sine graph. How did this function change? It's twice as tall, right? So I can see here, that was a little hard to read, but here it says in red that there's a 2 in the A slot, which makes your graph 2 times as tall. Now, A is also your amplitude. So now notice that if this is 2 times as tall, your amplitude is now 2 instead of 1. So when your A value stretches your graph taller, it also stretches your amplitude taller. So A is amplitude. Let's take a look at another one. Looking at this one, the blue graph here, the red graph is, it's tricky with the color here. The red graph is the original cos graph. What do you notice about the blue graph?
Narrower.
It's narrower, right? It got squished narrower. So I can see that the blue graph is cos 2x, which means it's only half as wide as it used to be. So notice though that when it's only half as wide, now the period is pi instead of before the period being 2 pi. So what your B value is going to affect is it's going to affect the period. And how it's going to affect the period is with this little rule here. The period is 2 pi over B. So I think you have that. I think you have that in a little box there on your page. That's very important. Again, the period for sine and cosine is going to be 2 pi over B. Because your B value is going to divide your period by whatever value it is. So here we have the red graph is the regular tan graph. And then the blue graph is an A value of 2. So you should notice that the blue graph appears to be a little straighter because it is twice as tall. So here the blue graph is tan 2x, and the red graph is our original tan x. So looking here, you can see that the blue graph occurs twice as often, or they appear closer together. So remember that that B value of 2 is going to make things squish your graph narrower, and so with tan, that makes it seem like there's more of them, or twice as many. Now, I want you to be careful here. The period formula for tan is just pi over B. That's because the original period of tan was pi. So now I'm taking pi and just squishing it by your factor of B. So period is different for tan as it is for sine and cosine. So just keep that in mind. All right, let's look at an example. So we're going to start by drawing the graph of 2 sine 1/4 x. Before we do this, it would be best to make a table of values of the original function. So let's start by making an original table of values of sine, and we're going to keep this all in radians. So here we're going to use mapping, and remember that your mapping equation is x over b and then ay, because here we have no h and k. So if my b value is 1/4, so that means I'm dividing by 1/4, and dividing by 1/4 is the same as multiplying by 4. So this graph is actually going to get 4 times wider. Okay, so my first point is at 0 and 0. So when I plug it in, we get 4 times 0 and 2 times 0, which is still 0 and 0. So it should make sense that 0, 0 didn't change because we're stretching it. Okay, so it didn't change. Then let's try pi over 2 and 1. So 4 times pi over 2 and 2 times 1 would give us 4 divided by 2, so 2 pi and 2. So the point pi over 2 and 1 is now at 2 pi and 2. Again, I'm just multiplying it by 4. Let's try the next point. It's pi and 0. So when I go 4 times pi, I get 4 pi, and 2 times 0, I get 0. Let's finish off the rest of our points. So notice the nice pattern that is created your x values go 0, 2 pi, 4 pi, 6 pi, 8 pi, and your y values go 0, 2, 0, minus 2, and 0. So it's going to make that wavy shape. Let's plot this on the graph. Right? So your graph would look something like this. Now we can look at the period. Remember the period is 2 pi divided by b. So in this case, b is a quarter, which means when I flip the 1/4 and multiply by 4, we get the period is 8 pi. And that should make sense when you look at your graph. Because your graph starts at 0 and makes one full rotation by 8 pi. Or it makes one full wave by 8 pi. So that should make sense that your period is 8 pi. The amplitude, again, is the height of the graph. Remember that the amplitude is your a value. So here your a value is 2, so your amplitude is 2. It also should make sense when you look at your graph that the graph is 2 units tall above the middle line. So for this one, we just need to start with our original coast graph, and then we're going to plug that into our mapping notation. So here when I plug into mapping, I'm going to get 0 and 1, which plugs into 3 times 0 over 2, and minus 3 times 1. So that's going to give us 0 and minus 3. So my new graph is going to be flipped upside down and stretched down to minus 3. The next point is pi over 2 and 0. So 3 over 2 times pi over 2 minus 3 times 0 gives us 3 pi over 4. Because 3 times pi and then 2 times 2 is 4. So my next point is going to be 3 pi over 4 and 0. Let's try another one. Let's try pi. So pi is at negative 1. So that gives me 3 times pi over 2. And minus 3 times minus 1 is going to give me positive 3. So 3 pi over 2 and positive 3. Now the pattern should be clear already as to what's happening to our graph. If you look, your first point's at 0, then you're at 3 pi over 4, and then 3 pi over 2. But remember, you guys, that 3 pi over 2 is the same thing as 6 pi over 4. So think about it as terms of over 4. We're going 0, then 3 pi over 4, then 6 pi over 4. So can you predict where your next point would be? 9 pi over 4, right. And then the next one would be 12 pi over 4. So you're jumping here by 3 pi over 4s. So let's finish these off. So here the x values are going by 3 pi over 4s. We're going to start at 0 and at minus 3 because it's been flipped. At 3 pi over 4, we're at 0. At 3 pi over 2, we're up at positive 3. Then at 9 pi over 4, we're back to 0. And at 3 pi, we're down to negative 3. So your curve looks something like that. All right, next we're going to try tan. So here our a value of tan is half, and our b value is 3. So I should already know that my amplitude is going to equal half. No, it's not. What's the amplitude of tan? Amplitude. It's undefined.
Oh, yeah.
Why is the amplitude of tan undefined? Because it goes up and down forever, so it doesn't have a height, right? But the period we can determine, because the period of tan is going to be pi over b, which is pi over 3. So now the period is going to be pi over 3, which means my tan graph is going to be shrinking narrower. It's going to be squished narrower. Let's start though with our table of values for our normal tan graph. Remember that now with our tan graph, we're going to be plugging in every 45 degrees. So we'll start at 0, we'll go pi over 4, pi over 2, 3 pi over 4, and pi. Because the original period of tan is pi, so I'm going to use those first 5 points up to pi. So you should get the following points here when you do your mapping. Now we're just going to put them on the graph. And we start at 0, we go up to pi over 12 and half, and our asymptote is located at pi over 6. On the other side, we go pi over 4 negative half, and pi over 3. Then remember, your graph has to hug the asymptote, so the period would look something like that. All right, so here we're going to determine this equation of the cosine graph. Remember that your cosine graph would normally start right here at 1, but this one's starting down at negative 3. So what did that mean? I multiplied my y values by? Negative 3, right? I multiplied the 1 by a negative 3 to to get it to go down there. So that means A is -3. Now let's look at B. B has to do with the period. So if I look at this part of the graph, it repeats itself at 4 pi over 4, which is pi. So a normal coast graph repeats itself at 2 pi, but this one's been squished to pi. So what does that mean my B value is? 2. It's 2. The B value would be 2. Because again, if you were at 2 pi, and now you squished it to pi, that means I cut it in half. So I'm dividing by 2. So that's how we just figure out the equation of a sine or a cosine graph. You just have to look at it and figure out what you multiplied by for A and what you divided by for B. We're then going to work on a handout for our assignment today.